Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Today we are in the third session of basic functionalities. Dear friends, Pandas is a library designed for data analysis and the data frame or the basic object on which all the related activities are carried out. So having an idea of their contents and their structure or the outset is important in order to better target the operations to be carried out. Among the basic activities, there is therefore the calculation of general statistics that can somehow give an idea of the values contained within the data frame under analysis. And dear friends, we will see many basic features that the Pandas library offer to obtain this type of descriptive data. So let me just start with the descriptive statistics. And inside the Pandas library, there is a function called describe method that calculates a whole series of descriptive statistics of the reference data frame. So let me just first create a data frame here with 10 into 4 with the data of total 40 values, and kindly have a note of it. We have created it through a random functionalities. Okay, now let me just provide the describe method. So this described, it is launched directly on the data frame to be analyzed, and as the result it is a table of descriptive statistics carried out at the column level and reported in the structure of data frame. So kindly have a note of it. I'm just going to execute this, and yeah, what we just get it? Yeah, I'm just slowly scrolling down and up. Kindly have a view of it, dear friend. So the statistics processed are also returned in the form of data frame, each of which is processed by a single column. And among the reported values, we see the element count, the mean and its standard deviation, the maximum and the minimum, and 3 percentiles. So when on just making to this, yeah, when we are having the 0th column, kindly just observe, yeah, of course, each and every column are we having here 10 data each. Okay, and the mean of each column, so of course it is the 0th column, first column, second and to the third respectively, and this is the standard deviation. And kindly just have a note of it. What is the minimum of the 0th column? Yeah, we are having, this is the 0th column's minimum value. No, it is not. So of course, what is the minimum value? Yeah, we just have 0.005790. Yeah, this is the exact minimum value. And of course, we have the maximum as 0.708238. So of course, dear friend, we just see that the element count, mean and its standard deviation, the maximum value of the each respective column and the minimum value, and of course the 3 percentiles as 25%, 50% and 75%. And have a note of it, dear friends, this information will be reported only for the columns of the data frame that contains a numerical value. So okay, if we have a data frame other than the numeric, what would be happen? So let here kindly have a note of it. This is the data frame here with combination of numeric and string, and of course boolean also there. So let us just execute it here. So when we just provide the describe, if we just want to have the describe, of course it is only for the numerical values. Yeah, here we just go with it, and there are no columns with a numerical values here. Sorry, other than numerical values. So here we just get only the numerical values of the number. So which we just have, of course, we have 5 numbers, 5 counts, and this is the mean of this, and standard deviation, the minimum value, maximum value, and other 3 percentiles. We just get it. Now, what we just receive for other than the numbers, we have to specify particular to the top column which we are having other than numbers. So other than with the columns with numerical values to be calculated. So it will present in addition to the number of elements presents other statistic such as the number of unique elements and the most frequent value for every single column with its frequency. So that is what we would just get when we go for other than the numerical value. So see here, this is other than the thing. So which we just get is count, unique, the most value, it is 1. So I just scroll above. So see here, the topmost is the 1, and of course we just get the frequency of topmost is false. Okay, so the frequency is 1 and here the boolean is 3. So this is what we just get when we just go with other than the numericals. So in the data frame with many columns, it would be a good practice to be able to select only a few columns, okay, without having to first make a selection of subsetting and then applying the describe as which we have just done before. So in this regard, there are two parameters. One is include and next one is exclude. So which allow us to explicitly specify which column should be included or excluded in the calculation of descriptive statistics. So the peculiarity is that you do not pass list containing labels, but you have to specify the data types. So that is the selection is made by the type of data. So kindly just have a note of it here. I'm just going to specify the integer. So of course we know, yeah, number, the column num is only which is having the integer value. So see here, this is what DFT2 and DataFrame 2, and here we just have only that num column has the numerical value. And yeah, coming to the next, dear friends, here there are several methods to calculate descriptive statistics and other related operations on series and data frames. So those mainly taken into the consideration are a whole series of methods taken from the NumPy library that are also applicable on the data frame. And here we are just going to see calculation of individual statistics. Okay, so the statistical evaluation by column is the default one, and you can also omit to insert the axis parameter. For example, if you want to calculate the mean of a value in each column, yeah, you can just provide the mean method here. And yeah, of course, here if you just want to make it to the column, kindly just observe to the column. If I just want to make, yeah, here I just specify it is on columns. Okay, so yeah, of course we have to specify 0 or the main attribute, it is axis is equal to 0. Okay, so let me just see here. Yeah, so we are having, so df1, yeah, of course, I just to show what is that in the df. So let I just have a scroll above. So this is what the df, and of course we have 0, 1, 2, 3, 4. So totally 4 columns is there. And yeah, we are getting the mean of each column. Okay, each column. So in fact, as many results are obtained as there are columns in the data frame, whereas if we want to carry out the statistical evaluation by the row, so the value must be specified, that is 1 must be specified here. Okay, so it is very much important. If you just specify axis is equal to 1, yeah, of course it is the correct exact method. So kindly just have a note of it. If I just specify according to the axis 1, yeah, here you can specify mean of 1. And what we just get, yeah, we are having totally 10 rows. And yeah, here it is the statistical evaluation by the row functionality. And next, let me just move on to the one standard deviation. And dear friends, a statistical value related to the calculation of the mean is the standard deviation, which is expressed in the function as like STD. So if I just make on to the DF, of course, we have 4 columns and 10 rows. Yeah, here it just provide me the exact calculation of each and every column. And for this type of statistical calculation, there are many methods that can be used directly onto the data frame. And dear friends, let's add a few more functionality to this. Yeah, add some standardization also. So this technique is widely used in the statistics and data analysis to make the different data series better comparable to each other. So making them standard. Okay, so let I just make this to be easy understanding. So these data groups are somehow aligned statistical in order to able to compare them more easily and highlight the difference. And in a practical way, standardization consists of making the mean of this group of value which is equal to 0 and standard deviation as unitary. Okay, so this can be done simply on a data frame, but also series also you can just follow it and kindly have a note of it. This is what the standard deviation. I just want to calculate it by mean and to that of standardization. Okay, and kindly just have a note of it when I execute this. So here we just get the mean value and next it is the one of standardized value. Okay, fine. So we will see some of the techniques that somehow rearrange the internal structure of the data frame by acting as the index level. In fact, dear friends, actually the order of labels within the data frame is not immutable but can be changed during the analysis. Okay, so there are therefore some techniques that act at this level include transposition, sorting and reindexing. Okay, so let me just start with the transposition. Dear friends, the transposition of a data frame is equivalent to the mathematical operation of the transposition of a matrix. So in this operation, the rows become the columns and the columns becomes the rows. So that is exact transposition. Applying a transposition to a data frame will therefore have the exchange of labels between index and the column. Okay, so with the consecutive reordering of the values related to them. So let me just first create a data frame and mix things. Okay, so here I have just applied the exact data frame as created with 1, 2, 3, 4, 5, 6 and 7, 8, 9. Yeah, of course it is what usually we just do with the same example. And having the index as ABC in the lower and the column with ABC as in the uppercase. So kindly have a note of it, dear friends. So this is how the exact data frame is. And how to make it towards the transpose? Yeah, to carry out the transpose of the data frame, it is sufficient to recall the attribute T. That is in uppercase. Okay, so it is what that. Okay, and yeah, kindly have a note of it. Yeah, thus we obtain the transposed data frame. So kindly have a note of it. This is the exact column. It has been converted as the indexes and the rows, that is the indexes A, B, C in the lower case now become the columns attribute. Okay, so yeah, fine. Now next, moving on to the sorting. Dear friends, often when loading a data frame from a data source, it happens that the order of rows or column is not the desired one. During the various analysis phases, we may wish to sort values of a specific column in ascending or descending order. Okay, all these sorting operations can be done by using sorting by labels or sorting by values or some thing sorting by both the values and labels. Okay, so let me just see one by one. And here we go with creation of a data frame. And dear friends, this exact data frame, yeah, let me just create a data frame with the inside of the index and column labels arranged in an unordered way. So it is practically almost a real data frame. Okay, so let me just create it. It is in an unordered manner. Okay, so that is what we have just given something as a random. Okay, now let we sort it by the label. Okay, let me just sort it by the label first. So the sorting by label is based on sorting the label in axis or column based on their value. And it is performed efficiently by the method called sort_index. Okay, this is the exact method. And by default, this method puts the label on the index in the data frame, and defaultly it is in ascending order. So matching the value on each row will allow how to make them in the follow in the same order. Okay, so let me just make it. So this is our data frame. Of course, kindly have a note of it. This is our data frame, and this data frame, when we want to sort it, and of course we are just going to make it into a data frame 2. So kindly have a note of it, how it has been ordered. And as we can see from the result, the rows of the exact data frame have been reordered and following the ascending order of the index labels. So we therefore had a sort order by row, while the order of the column remained unchanged. So if on other hand, if need to sort the labels in descending order, of course we can simply add the ascending parameter and set it to the false. Okay, so that is what the very simple manner. So kindly have a note of it. So yeah, here we just go with the same thing, and I just want to make it in a descending order. So see, descending order D, C, B and A, where in the 15th cell we just got A, B, C, D. Okay, and yeah, of course, if you want to have a note of the original created, yeah, it is in unordered B, D, C, A. Okay, now, yeah, dear friends, if we want to sort the label in columns in ascending order, okay, it will be necessary to explicitly define the parameter axis. Okay, so axis is equal to 1. So by default, the axis always would be 0. And if we just specify it as 1, yeah, it is related to the column. So let me just pass it and execute it. And see here, dear friends, this is the exact sorted manner. Yeah, do you want to have a look of the original? So let I just go above, and here we just go. So here, kindly just observe C, D, A, B. That is what the exact original data frame. And now we have sorted in the ascending order. And to the same, if you want to make it in a descending, of course we have to use this ascending attribute and make it as like a false. Of course, yeah, here we just have provided the axis is equal to 1. So it is related to the corresponding values on the column. So see here, DC, B, A. Okay, now if we want to sort by both row labels and column labels, so we can do it safely by chaining the method. Okay, so chaining the method, yeah, of course, dear friend, first we sort the data frame first by the row and then later by the column. So see here, first let me just make it by the row. So axis is equal to 0 and chaining it with the axis is equal to 1. That is what we are just making it towards the, kindly observe, A, B, C, D in the row wise and A, B, C, D in the column wise. Both are in the sorted manner, and which is in the arrangement of a chaining methodology. Okay, now next it is all about sorting by values. Dear friends, another way to sort a data frame is to sort the row or column according to their contained value. So sorting by value is done by the exact function sort underscore values. Okay, so in order to work, this method needs a mandatory parameter that must be explicitly set. That is the by parameter. That is must be labeled column. So according to which the value within the column will be sorted in the ascending order. So kindly have a note of it. This is what the by parameter, and here I just want to make it by uppercase A. So it resembles to the exact column wise. Okay, so kindly just have a note of it. That is what the contained value to be there in ascending order. So see here, dear friends. So this one A, it is in ascending order 4, 4, 6 and next one is 8. And as can be seen from the result, the data frame has the value of column A in the ascending order. And consequently, the order of the corresponding row of the data frame has also changed in the same following order. Okay, the by parameter can also accept a list of column labels. So the sort value method will first sort the column values corresponding to the first label in the list, then in the context of the equal value present in this column, it will sort on the column corresponding to the second label in the list. And yeah, let me just have a note of it here. I just want to make it, one is for A and another it's for B. So kindly have a note of it, dear friends. So the B, which is not in the order now, once I just want to make it towards the ascending. So kindly have a note of it, dear friends. So first I just want to make it in the value of 0022. First I have just assigned it, and now it has been done for the B also. So as we can see from the result, the value of column B will be reordered limited to the range of identical values present in the column A. So here for the specification of identical value, this is provided 0, 0 and 2, 2. Okay, so although it in the simple example, it may be trivial, this combined sorting will be very useful in data frame where there are many rows with data on some columns whose value repeatedly noticeable. Okay, so yeah, finally both the things, let me just make use of the index method and sort values. Okay, so yeah, will not modify the original data frame but will return an ordered copy of it. Any changes made to the later will not affect the original data frame in the list. So kindly have a note of it here. I'm just going to make it. So this one, I'm just going to apply it on, first of all, kindly have a note of it. I'm just going to print the original data frame with the sorted order. Okay, and I'm just going to make it in the DF2. Okay, so see here how this is happening, how the exact copy of the functionality is applied. So this is what the CDAB, okay, and of course here we have just done towards the AB and CD according to the axis 0. Okay, according to the axis 0, it has been sorted. And so if we want our changes to be final, yeah, it will be necessary to assign the data frame returned by the function to the starting data frame. Okay, so that is also can be done. Yeah, I just apply it towards the value by parameter. Okay, and let me just observe it. So see here by parameter, I'm just going to apply it on to this. So it is in the sorting of the original. Okay, now let me just move on to the next one, re-indexing. Dear friend, re-indexing is the fundamental method of aligning data in the Pandas. So reindexing means conforming the data to match a given set of labels along a particular axis. So this involves a set of things which we just say as reordering of an existing data to respond to the new set of labels, or the insertion of a null in the position where there is no correspondence, or possibilities of filling in the case of that missing, that is a null which the special data. Okay, so let me just make use of it. First of all, let me just create a data frame. Okay, and of course we are just going to create a data frame with 4 into 4 as our size of the matrix, and here it is our index and the column. Okay, so let me just first form the data frame. Okay, and yeah, dear friends, to reindex, let me just use the reindex method specifying the new order of the labels that the data frame must have. Kindly just have a note of it. It has to be there. Okay, the method will not operate on the reference data frame, but will return a copy of the data frame that will follow the new indexing rule. So to select with which particular index object will be reindexed, here we will add the access parameter with its specific value as a function argument, as like access is equal to 0 or access is equal to 1, as like that. Okay, so yeah, first of all, let me just make it onto the row functionality. Here I have added access is equal to 0. So let we execute and see it. Okay, now kindly have a note of it, dear friend. This is what reindexed. Of course, the original is BDCA. That is what the original indexed. And of course, it is reindexed as like AB, CD. And as you can see, the order of rows of the data frame has been completely changed. And following the order in the list of the labels, in the list of the labels here, it is specified as the argument of the method. And yeah, dear friends, the new data frame will be a completely independent copy, and any changes made to it will not affect the original of it. Okay, so kindly have a note of it. If I just want to make the same functionality here, so see here, this is what the exact 1, 1. I'm just going to change it to the 0, and kindly just to see what is there in the df2 and the df. Okay, so 1, 1. So this is what my 1, 1, and kindly just to see here, dear friends, it is not affecting the original data. It is not affecting the original data. Okay, so the same, let me just goes for the column wise. So let I just make it for the axis is equal to 1, and kindly have a note of it. Yeah, to this original, our order of the column is CDAB, and yeah, what happened when we just want to make it to the arrangement? Yeah, kindly have a note of it. Yeah, it is arranged as like A, B, C and D. So how we have provided the same thing in the row wise. Yeah, here also by using axis is equal to 1, we have done it as a column wise. Okay, now kindly have a note of it, dear friends. What happen if we insert a label that are not present in our original data frame, or if we commit some present labels or any other like that? Okay, so kindly have a note of it. Instead of B, I have provided an value as like E, which is not there in the existing df. Okay, so let I just give it and execute it. Kindly observe, dear friend. Yeah, as we can see, if a new label is inserted in the reindexing, yeah, the method will create a new column, or even though you can just apply it the same thing in the row wise also. Okay, but how it just have? Yeah, it just have it containing the values would be in NaN, that is a missing value. And while if you do not report an existing label in the reindexing, the columns or the row will be removed in the new returned data frame. Okay, fine. Okay, now let me just make the reindexing using another data frame as a reference. So here another data frame, I just want to make it. So there is also the possibility of using a reference data frame from which to take the order of the indexes. So what is in the indexes? As like, yeah, both by row and by column, and apply it to our data frame. Dear friends, this exactly is possible with the reindex like. So let me just create one of the data frame here. So kindly have a note of it here. I'm just going to make it with the zeros, okay, in 4 into 4, just providing the index and the column as we decide here. Okay, so now we will apply the reindex method on our data frame on which we want to reindex. So here, yeah, this is DFO is the exact data frame and we want to apply it, and kindly have a note of it. This DF which I just want to apply onto the reference this. So have a note what would happen. So 3849, 3844. So all the things which is original from this data frame. So this is how the original DF. Okay. Also in this case, if the reference data frame, there are labels that do not exist in our data frame on which to index, that is these rows or columns will be added to the new data frame, returned with all the null values. So kindly have that in the mind. So yeah, of course, let me make that too. So see here, dear friends, that is what, yeah, we are going to include one of the index as E, and to the column W is at, yeah, which is not in the existed one. Yeah, we are just going to make it towards the indexed. Okay, so that is the reference. So let we reference it and apply towards it. So how it happens? So yeah, as we have already discussed, yeah, wherever the exact, if the reference data frame, some labels that are not present, the corresponding rows or columns will be removed from the new data which is returned, and of course it would have the new data with NaN, which we just specify as like missing. And yeah, dear friends, this session, of course, I think we have just done with the basic functionalities. Yeah, next we are just going to continue with the advanced functionalities. And dear friends, if you want to take your learning to the next level, kindly join us on the exciting journey. Don't forget to hit the subscribe button and turn on the notification bell. Let's see you on the next advanced functionality of data frame session. Thank you, dear friends. Happy learning.